Okay, so what is dbms? So are you guys aware of what is dbms, like dbms softwares? Hello.
It's a database management system.
Yeah, it's a database management system. So basically it's a software. Okay, software in the sense, if you could see, this is MySQL workbench, right? So in this class, in this complete course will be, whenever we are talking about SQL, or whenever we are doing hands-on on SQL, so we are focusing more of on MySQL. Okay, so and we'll also, contrast whatever commands. Let's suppose we have done some script. Okay, we have created some database, or we have created some SQL query. So that query we will try to contrast, I mean, we will try to relate it with another database as well, like PostgreSQL or MS SQL Server, or Oracle DB likewise, so that you will be able to master not only MySQL but also some other databases as well, so that whenever you write on your resume, you will be able to uh, you know you will be able to showcase that you have worked on MySQL as well, Oracle as well, PostgreSQL as well. So in this class, in this SQL session, we'll be focusing on MySQL Workbench. So basically MySQL. So we have DBMS software called MySQL, and the database is MySQL Server. So basically, a database management system is a software that is designed to manage and organize the data in a structured manner. So it allows users to create, modify, and query a database. So basically, here we have MySQL. So in the same way, we have a PG admin. So that kind of PG admin for PostgreSQL, simple workbench for all other databases to connect. So likewise, so now we are using MySQL. And when coming to what is RDBMS, so RDBMS is nothing but Relational Data Management System. So it says Relational Database Management System is a collection of programs and capabilities that enable IT teams and others to create, update, administrators. Otherwise, okay. So basically, what is relational database? Okay, so what is a relational database? So relational database means, so it's a collection of information that organize the data points. So basically, relational database means you will be having database. Okay, you will be having tables inside that. You'll be having columns and rows inside the tables. So that is a relational database. So we have NoSQL database as well. So that we will be talking later on. So now relational database means structured way. Okay, structured way of doing, organizing the data. Structured way means, like, you'll be having, let's suppose if you open Excel sheet. If I open Excel sheet, and this is a structured way of writing, organizing the data, right? You will be having columns, you'll be having rows. Let's suppose if it is a name, and then you have city and age. Okay, these are columns. And then if you have name Vinay and age Toronto, and then age is 37. So this is, structured way of writing the data. Okay, sorry guys. So yeah, so this is what. So basically, so this is a structured way of storing the data, organizing the data in the like tables. I mean, in the table as a column as well as row. So basically, you'll be having a columns and records as well. So that is what RDBMS is. So structured way of storing the data. So that is RDBMS. So when coming to RDBMS data, software, we have MySQL server, we have PostgreSQL server. So if you could see RDBMS softwares, so you can see MySQL, Microsoft SQL Server, PostgreSQL Server, MySQL, and SQLite. So there are so many RDBMS softwares. So when coming to DBMS softwares, so you have MySQL. Sorry. So yeah. So we have RDBMS, right? So like both database management software. So MySQL, Oracle, and MongoDB. So everything related to database management software. So one which we are working on is MySQL Workbench. So this is also a database management software. But in that, so we have MySQL server installed. So we'll be able to query using this MySQL Workbench. We'll be able to query this MySQL softwares. Sorry, database management softwares. So for this, so for MySQL Workbench, so we will be most of the time we'll be using MySQL Workbench itself. So in case of PostgreSQL, we'll be having PG admin. So this is a PG admin for PostgreSQL. Likewise, most of the databases provide some of the other software to interact with their databases. So are you clear with DBMS versus RDBMS?
Yes, sir. Yeah.
Okay, so if you want, you can just type RDBMS versus DBMS. Okay, so here DBMS data is saved in file formats and data is saved in table format. So completely, so data is saved in table format. So if you could see, so this as I said, a relational database management software. So that means relation means basically tables. Okay, relation means basically having some relations, some kind of tables, rows. So each row is designated for particular employee. Let's suppose you have employees table. So if this is the employees table, so this particular record is entitled for Vinay, right? So his city is Toronto, his age is 37. So likewise. So and then normalization is not possible. So these things we'll be talking on later on. So as of now, you just need to know what is database. So let me uh, show you the hierarchy how database looks like. So if you could see, so we always have database and then schema and then table, and in on top of the table we will be having columns. Inside the table we will be having columns and rows, right? So database in the sense, so now in MySQL, okay, in MySQL we don't have schemas. So in PostgreSQL, generally, hierarchy, this is the hierarchy of every database. So hierarchy in the sense, whenever you're calling some table, okay, let's suppose you'll be having database and then dot schema name and then table. Okay, so this is basically nowadays every database is having this kind of hierarchy. So let's suppose if I wanted to select some data, select star from. So this, if you take this piece of code and write it here, so this is how you will get the data from particular table. Okay, so previously in MySQL we don't have schema kind of approach. Okay, so we only have select star from database dot table name. So this is one way. Okay, so PostgreSQL have this, Redshift have this, and some other new databases like Snowflake also have this kind of database schema table kind of approach. Hierarchy, I can say it as hierarchy. So this has this, MySQL has only table and database dot table, uh, like there itself. That is a hierarchy now we have in MySQL. So whenever I am referring, so I'll just refer to the MySQL, and I'll try to relate with some other databases as well. Because directly we are having schemas over here, but in other databases you will be having database, in that you will be having schemas, but in MySQL, so we directly associate with the schemas directly. So that's why we directly, call this as a database. Inside that there will be tables. If I just open this demo DB database, you will have tables. Okay, so likewise. So so this is all about database and schema and table. So you will be having a database. Let's suppose you have a database called schema. Sorry, school. Okay, school is the database, and in that school, in that school you'll be having teachers. That is one schema, teacher schema. Okay, and in that school you'll be having one student schema. So teacher schema and student schema, right? In that, so under this teacher schema you'll be having few tables. Tables called maybe teacher teachers details table. Maybe that can be a personal details, and the other database teacher salary details table, and then teacher schedule related table. So you'll be having like this. And when coming to student schema, you'll be having students details and students addresses and students financial details. So likewise, this is how you'll have real data modeling would look like. So school is a database. Under that you will be having database is school, and under that you'll be having teachers, and under that you'll be having students. Two schemas. Okay, you can have like a number of schemas in a database, and in that database you can have a number of tables in that particular schema. Okay, so database is school and teachers is one schema, and other schema is students, and in that schema, so you'll be having a number of tables. So that is how organize your database in real time. So now, in our case, we'll be just focusing on how to query the things and how to, learn SQL. But here, this kind of data modeling will not be, you won't look like this. It won't look like this because we are just trying to explore SQL commands and SQL scripts. Basically, try to explore the functions, like everything. So it won't be looking like this. But if you could see any real-time projects, you'll be having, you will be having this kind of organization of data. So that is called data modeling. So basically, you design a database, right? So that is what uh, this database, school and teacher schema and student schema, in that you'll be having tables. So are you clear till here how you organize the data in a database? So as a data engineer, you won't be doing these specific things because these things are more of a web application related when coming to this database. So this is OLTP database. So if I talk about what is OLTP database, what is OLAP database? So let me explain what is OLTP versus OLAP. Okay, so let's suppose you have a web application called Book My Show. Okay, so we have Book My Show. So what you will be doing with the Book My Show web application? So you will just try to like movie tickets, right? So these tickets, these tickets details are stored in OLTP kind of databases. Okay, OLTP kind of databases means MySQL, MySQL, whatever we are using right now. So that is OLTP database, and MS SQL Server. Okay, MS SQL Server is OLTP database. So this, OLTP databases stored like day-to-day transactions. So here, if you could see, OLTP means online transaction processing. So basically, this is day-to-day transactions. So you're booking a ticket to ticket on Book My Show. That means so it should be it should write fast and read fast, right? So that is what these databases are. So you will be able to write it fast and read it fast. So when coming to OLAP databases, OLAP, so that means online analyzing processing. So these databases are used for analyzing purpose. So basically, so you have one data engineering project, and you have that data engineering project, and you are having the destination database as Snowflake, okay, or Redshift. Let's take it Redshift. So it stores huge amount of data. So like a huge amount of data in the sense, so if you have olap database as Redshift, so this is the destination of any kind of data in data warehousing project. So now what you will be doing, so you have some csv files. Okay, if you are aware of csv files, so if you are not aware of the csv file, let me open any csv file in my comma separated file. Basically it's a comma separated file. If I open my AWS project, one of the AWS project, we have source file. So this is the CSV file called orders. Okay, this is the CSV file. So in any of the data engineering project, how you will be doing? So you will have this kind of data coming from different source systems, and you will load this data till Redshift layer. Okay, Redshift layer in the sense, uh, Redshift database. Okay, this database, the final database. So this database is used for analyzing purpose. Okay, these databases are used for website purpose, for just to read the data, write the data over the website. Okay, so this data is used for that transaction processing. But this database, whatever data we have in Redshift, you will just try to analyze it. Okay, analyze this in the sense, you will just read the data from the tables and create the dashboards in the Power BI or Tableau, or you will just try to report the data. I mean, create some Excel sheets and send it to the business or stakeholders, so that they'll be deciding and creating some uh, good decisions. So that is what analyzing processing database, OLAP. So you generally call this as OLTP database, and this is OLAP database. So now, as a part of SQL, so we will be talking on MySQL, right? So whatever queries we learn, so whatever SQL statements that we write, whatever you learn here in this 10 sessions, so that queries would work in MySQL, sorry, Redshift, as well as Snowflake, and as well as so BigQuery. So this all are comes under same category: Snowflake, Redshift, and BigQuery. So if you are going to any data engineering project, so either any of these would be the destination database. Okay, if you go to any job posting, you can see anything, any job posting, you will be able to, you know, see that there is a requirement for Redshift in this project. So Snowflake experience in Redshift or Snowflake or BigQuery is preferred. So this kind of thing would be there. So basically, whatever you are learning in SQL, so that queries you can, that queries will work in other three databases as well. So because we, any database that should follow some ANSI standards of SQL. Okay, ANSI standards means, uh, so there are some standards. So basically, this institute set some standards for following some syntaxes. Okay, so now MySQL, we have MySQL server, we have PostgreSQL as well, we have MS SQL server. So there are different softwares, dbms softwares, sorry, rdbms or dbms softwares are there, right? So basically they has to follow some standards. So if you're trying to write create statement, okay, create table statement, let's suppose if we are trying to write create database and my demo db. So this is something demo db3. Okay, this same command should work in MySQL as well as PostgreSQL and other databases as well, because they have to follow some practices where set by ANSI Institute. So basically this are the standards they have set. So if you wanted to add new functionality, let's suppose MySQL wants to add new functionality apart from this, so it's okay that they can add new functionality, but the minimum standards they have to follow actually. Okay, so that's why if you know MySQL, so then means you also know PostgreSQL as well. So if you know PostgreSQL and MySQL, you can also work on MS SQL Server as well. So that is what, if you know simply ANSI standard of SQL, so it you can work on any other databases as well. So are you clear with this till here? Am I fast or are you clear till here? Okay, okay, perfect. How about you, Priyanka and Akhil?
It's
Yeah, you can
clear.
unmute yourself. Okay, okay. Yeah. So, and when coming to the DBMS theoretical topics, so if you have time, you can go to that. Otherwise, we will also get into the hands-on. So, what I basically do in the sessions is like I try to create most of the interactive and hands-on sessions. So, but yeah, today as a first class, I'll go through theoretical part as well. Okay. So basically, normalization. We'll go through normalization. Okay. So introduction of database normalization. So basically, generally, if we have one table, okay, let's suppose if you have one table, so we have students table. Okay, we have students table in that what columns are necessary. Student name. Okay, student name. Let me shortcut it and st name, comma st id, comma maybe class of the student. Okay, which class he is studying into, and then course details. Okay, yeah, course detail, whether he's bachelor's or master's or something like that. So you can also add address and then city and then maybe pin code, something like that, right? So can you normalize this? Can you normalize this to another table? So how can you segregate this table basically? So can we make this like student name and student ID in one table and class and course in one table? And can you make another table called student address and take this one, right? We can divide this students table and create two, from this one table, you can create two more tables, right? One is students personal info, some students info. Let's write at students info, student info. Okay. In this, you can name it as student name, comma student ID, comma class, comma course, right? And one more table you can name it as student address, student address. Okay. So let me add student ID because I just wanted to have relationship. Okay, relationship between the students table. So and then student name as student table and students info table as well as student address table. I just wanted to have relationship. Okay. So I'll just write student ID and I'll just write address, comma city, comma pin. So now you can say that this students table, these are normalized. So that means this is denormalized. Okay, denormalized means keeping the information, complete information in one table. So that is called denormalized. So if you're normalizing into two or more tables, so that is called normalization. So now it's clear, right? So it's clear in the sense, if you just need student name, so you'll go and search in student info table, right? If you just need student address, you will go to students address table and search for the address based on the student ID. So from this, you will just search for student ID. Okay. However, you will be having student ID, something like some 6-digit number or something. Okay. So now you know the student ID, and then you just wanted to find address as well as name, right? So, but name is in some other table and address is in some other table. So two different tables, right? So what you will be doing, you will just try to, relate it with some ID. If you could see, there is a relation that is student ID and student ID. So now if you try to get this information from the address table, and you can just try to get information from the students table with, student name. So you will join both the tables. So this concept, you come across in later sessions. So joinings, subqueries and all. So but yeah, so this is normalization concept. So if you could see, you can also add all the things in a single table, but that means your table is not normalized, it is denormalized. So now we'll be talking on normalization. Before getting into the topic, I just showed you the real time example, how how you normalize the data base or database tables. So database normalization is a process of organizing the attributes. So basically attributes in the sense columns, okay? Columns or tables of the database to the reduce or eliminate data redundancy having same data but at a different places. So if you could see, so we have students table. Okay, this contains three information. What if I have another table called student address and store the same information in other table? Again, if I have address and city and pin in some other table called student address. Okay, so if I have this, okay, leave about this. Okay, forget about this. This is normalized form of data. But so if I have this kind of one students table and students address table, and if I have student ID. So this makes some data redundancy, right? So basically you are storing address over here in address table as well as students table. So data redundancy means basically repetition of the data over again, in some other table we have address table and in this table also we have address. So it is, basically consuming more space. So even though you don't require this two times, so even though you will be able to access this even if it in single table, but you are having this data in two tables. So that means data redundancy. So data redundancy means basically repeating the data or having some data, same data, but at this different places. So it's a process of eliminating those things. Okay. So if you could see here, we have eliminated, like we have eliminated this thing. So students info, you have these three columns, and for address, so we have in this. So if you want student name and student address, you will just try to join these two tables and show the information to the user, or any, maybe you will show the information to someone else who requires it, right? So this is normalized and this is denormalized. So in order to remove this kind of redundancy and make to this table, so to this table, like this two tables, so we are following some practices. Okay, that is called normalization uh, forms, basically normalization forms. So basically we have 1NF, 2NF, uh, BCNF. So there are the way goes forward, like 1NF is bit organized. Okay, 2NF is some more organized, and BCNF is more organized. So likewise we have four or fifth normal form. If you are following fifth normal form, that means your query, your database is more organized and more normalized. So that is what normalization is. So you don't need to remember what is 1NF, 2NF, 2NF, and this all things. Just remember this concept. Like no one will be asking in this kind of questions unless you are a very fresher or something like that. What is normalization, this kind of questions. But I don't think so. You will be applying as a fresher completely, so no one will be asking. So if you want, you can go through this what is 1NF. So whatever at a high level, so what we spoke is that is a normalization. So this is at a high level, that, like dividing the data and organizing in different forms. So but if you could see the definitions over here, it is more of low level, like they will be talking about multi-valued attribute and all. So you might not be able to understand if you go with these definitions, but ultimately organizing the data. So whatever we spoke about this here, so that is turned into the theory. That's it. So if you could see, if you go to the this table, so conversion to first normal form. So if you could see, we have this normal form. Okay, this is 1NF. So if you could see one table, we have student number, student name, and student phone number. We have multi values. Okay, multiple values for two numbers. For single record, we have two phone numbers, right? So how you can convert this in a more of organized way? So you can take this piece of this mobile number and then create one more row, right? You can take this information and create one more row into one RAM, and then the other phone number, and make it Haryana. So whatever we have already, right? So this is conversioning multi-valued variable, okay, multi-valued data in a column to one more row. Okay, so this is first normal form. So if you go again to the second normal form, it will be more of organizing the data in a better way. So that's it. Like organizing the data in a better way. Like if you go to third BCNF, then we will be having few more examples. But finally, you will have, finally you will have the data in this way. So at a high level, this is what normalization is. So do you have any doubts still here? So don't worry about this theoretical part. What is one NF to NF? But something normalization is something you are organizing the data in order to eliminate the data redundancy and yeah, data repetition. Yeah, that's it. So why generally the problem is why we need to remove the redundancy, because if you're storing the same data again and again, okay, if you're storing the address in one student's table and again address in student address table, so it is a redundancy and it also consumes the space as well. So that is what this should be. That is why this should be organized in a proper way. But sometimes denormalization also helps because maybe in data engineering projects, so some files, you have different 4 or 5 different tables, and that particular data, I mean, whatever you build a query where you get all information from that tables and create or like write it as a file. So that is what denormalization is. But yeah, so there is a purpose for creating that files as well. But mostly the database should follow normalization techniques. So that's it. So are you clear till here, or do you want me to explain anything else? I mean, do you have any doubts here till here? Satya, Sandeep.
Go on, Vinay. Like,
So you're clear, right? So what about normalization?
yeah,
Okay, how about you, Satya and Akhil? Satya, are you listening to me or? Okay, no worries if you have some background noise. So just type in the chat if you're clear, then we can proceed to the next one. Or else it's 4, so we can wrap up and next we'll continue from tomorrow as well. I mean, tomorrow it will be more of hands-on. Just we will go through hands-on itself. So you can go through basic database management related questions, or I can say maybe theoretical things like what is normalization. Just go through Geek for Geeks or whatever that comes to your Google first priority. So you can go through those like what is dbms, um, what is normalization. So but don't go in depth to that because you won't be working completely on oltp databases. So you'll be working on sql, building the query for data warehousing likewise. So normalization and this one nft, don't try to understand this complete theoretical part, because at a high level this is what normalization is, just organizing the data, removing the redundancy. So whenever you look at the table, you'll be able to figure it out how to divide the table into two different tables, right? So if you look at this particular, if I remove this, if you look at this particular table, you know how to divide this table into two different tables, right? If you look at this student name, student ID, class, course is there. So maybe you can, you will be able to understand that this could be divided into one table, and if address city can be divided into other table called addresses of the student. So likewise, you will be able to, uh, easily understand by looking at this information, right? So that is enough for us. So I don't think so you have to go through complete definitions. So this would make you more complex, but but if you could directly go to the example and check what happens here, so you can see multi-valued variable is converted to say one more row, right? So that is what you'll be able to understand. Rather, if you go to this um, theoretical definition, you might not be able to understand properly, but try to go to the example and check what it is, what happening after converting the basic table from normalized first normal form. And once after that, you can go to the second normal form and tries to check, try to check what happened here. So I don't think so. We don't have correct example. Okay, we have this one table, right? So consider this is the table, and then this is divided into two tables. One is student number, student course number, and course fee, and this is course number. So I think, yeah, so this two, so this is one table, course number and course student number and course number and course fees another table. So this can be divided, right? Based on the course number, you will be able to again join it and get the information if you require. So that is what it is doing. So what basically we have one table called student number, course number, and course fee. Okay, so you can divide this, right? Basically, one student we have one student. He is assigned with course one, course C1, right? So that is 1,000. Okay, the C1 again, the C1 we also have 1,000. So now you can create this table into two tables, right? So because this course for C1 course, however, it is 1,000, right? For C1 course, again we have 1,000, C2 1,500, and C5. So likewise, now you can create a one more table called courses fee info. Okay, course fee info. You can have course number and course fee as a separate table. Okay, now you can have one more table like student course info. Okay, which course, which student has been assigned to which course, so that you have two tables. One is course info, I mean course fees, something like that, and other one is student and course info. So one student number one is assigned to C1 course. So in one table you'll be having these two columns, and other table you'll be having these two columns, and in one table you'll be having these columns. So that is what it's removing the redundancy. So this is 2NF. So as on you go to the final fifth normal form, your data is more, more eliminating the more redundancy. So that is what normalization is. Okay. So again, tomorrow we'll be starting with, primary key. What is primary key? What is database? How to create the database? How to create the tables? And how to create, write the data, like data types and all. So we'll be focusing more on hands-on tomorrow. So yeah, before coming to the tomorrow session, just try to explore more on what is dbms, what is rdbms. So what are the softwares we use for, connecting to the databases, and what are, basically what is a table. So basically if you spend at least half an hour with, researching on the dbms, so we'll be able to do hands-on directly, and then if you have any doubts we can discuss tomorrow as well. So for now, we can wrap up the session, and tomorrow we will do complete hands-on on SQL, MySQL. So if you wanted to install this on your computer, so I would suggest you to go to MySQL Workbench. You can go to the Google, YouTube. Okay, you can go to the YouTube and just search for installation of MySQL Workbench. Just try to install. So I want you guys to install this all the things, because parallelly I'll share the queries whatever we do in the class. I'll share complete script so that you can execute after the class as well. So that you will also able to, do the hands-on, and you'll be confident on the things whatever I am doing in the class. So you can do, and if you have any doubts, you can also share your screen and show me the queries, show me the issues that you are not able to solve. Just try to Google it, installation of MySQL Workbench. So follow the same procedure and install in your computers. So that you can do parallelly whatever we are doing in the class.
Hey
And
Vinay, instead of using MySQL Workbench, can we also do in
Yeah.
SQL Server Management Studio 19?
Yeah. Yes. Okay. MS SQL Server, right?
Yeah, because I have it already in my laptop. So instead of again downloading the other version, like the other
Okay.
application.
Yeah, no problem. You can do it. So, but we are focusing on MySQL, right? So let's suppose in MySQL we have stored procedure in a different way. So in my MS SQL server, you have to write that stored procedure in a different way. So that you can convert it from MySQL to MS SQL server using any of the technology like maybe Chat GPT, or you can just you can get it from internet as well. But whatever I am teaching, so it will be more of MySQL. And the contrast, as I said, I'll try to make it a comparison with different syntax and different database. Yeah, you can use that as well, but it would be great, I will share the
Okay.
scripts, right? So if I share the script, you can directly
Yeah.
execute the scripts in your laptop. That is more of compatible with MySQL only. But if you can explore, you can explore with that as well. That will make you more you will be able to understand more as well if you try to execute this MySQL scripts in MS SQL server. So you will also understand MySQL as well as MS SQL server as well. So I mean, I don't think so it's no harm in doing that. You can do it in MySQL MS SQL server as well. So it will increase your it's better for you as well. So but if you want it
Yeah. Then,
if you don't want
I will install
to
this one.
learn, yeah, you can do both the things. It will be beneficial for you itself. So if you use
Okay,
MS
thank
SQL
you.
server, you will be understanding MS SQL server as well. So both you will be able to benefit.
Fine.
And
Yeah.
Thank you.
Okay.
Vinay, I gone through many videos and I searched in Google for what a real data engineering do in the real world in the real time projects. And
Okay.
can you just briefly explain what's the role of a data engineer in in the real time?
Okay. Let me share my screen. Yeah. So generally, so we spoke about a CSV file, right? So this one is a CSV file. Okay. So this is the CSV file, and we have the CSV file with 10 records. So this is called source. Okay. Source system. Source system is who gives the data, who provides the data. So let's suppose if you talk about healthcare client, okay, healthcare healthcare client, this get data from different sources, and this data can be from different sources. That means you might get CSV files daily from 10 sources. 10 source systems we have, 10 sources, 10 CSV files we get based on the agreement. Okay, like let's suppose this is global project, so you can get the CSV files from different countries, maybe Australia, New Zealand, even India. And this complete data, 10 source systems data, should be stored in single point, okay, single destination. That can be Redshift. Okay, if you are using AWS, so that can be Redshift. If you are maybe if you are using AWS, there might be possibility of Snowflake as well. But yeah, more of AWS is integrated with Redshift. So Redshift is a AWS database. So we will be using Redshift more of. So so in order to process this data coming from different source systems and loading it till Redshift, so that is what data engineer work is. So building the pipeline. So basically building the pipeline where it read the data from the S3 bucket where these CSV files are available. S3 bucket means basically for storage purpose. So we will talk about that later on in AWS sessions. So let's suppose we have this file, this file is available in source file, right? Let's suppose this file, I will read this file, okay? And then this file go through some, right now if we could see, we have some data redundancy here. I'll just check for some wrong data here. Mm, okay, I couldn't find exactly wrong data here. Okay, let's suppose there is some issue. Okay, we have got data 2023 hyphen and this, but what actually database accepts? It accepts this format hyphen 2023/03/10. It's not a date format actually. It's a format of basically string kind of format. So I wanted to change this to hyphen just to make compatible with database. So I'll read this file directly, and then in different layers. Okay, we have different layers. One is landing layer, okay, where this file gets placed in S3 bucket, and this file you read it and place the in landing layer we will be having some tables. So in this layer you'll have some table called, this is orders table. Okay, let's suppose if it is orders table from some from one source system, orders source system one, source one. And we also get one more orders table from orders, we may name it as order source 2. Okay, like this you'll get n number of CSV files, Parquet files. It depends on the source system's agreement. So if they are sending CSV files, it's okay, we will take it. If they are sending Parquet files, it's okay, we will take it. Even if they are giving the um, URL of their database, okay, like this we have database, right? So in that way, if they are providing connection details of their database, so that's also okay. So we'll just try to connect to their database using connection strings that they provide, like endpoint URL, password, username. So we'll just try to connect the connect and like create a query like selecting some data from the table, and using where condition we will filter out the data, like the most recent data. You will just try to take it, fetch it, extract the data, and process the data in our system, in our application, basically in our pipeline. So now you have this thing, right? So you created order source one. So how you created? Using some script, right? Python script or Spark script. You just read this CSV file which is available in one folder, and you just read this data, like reading the data. Okay, basically reading the data and writing into our table, this order source one table. And in the same way, in other data pipeline, okay, this is one data pipeline. In other data pipeline you read some other CSV file which which is from different source, and finally load it to some for finally load it till some kind of data processing layer or gold layer. Okay, maybe silver, this is staging layer. And then that is landing layer, and this is staging layer. Staging layer means some cosmetics things you try to manage. So like here we have date format is this way, right? You'll transform this to hyphens because that is the one which database will be accepting. Okay, so this you will change it to hyphens. In the staging layer you will do some cosmetics things. Cosmetic things, I'm writing in a layman language. Cosmetics things means this can be order ID. You can name it as order underscore ID, right? Order date, order underscore DT. So product category, you don't need to be have like this PRD underscore CAT. So likewise, you will do some cosmetics things in the staging layer, right? Again, you will have data processing layer. Okay, I'm writing it in a simpler way, but in some projects you will be having 3 or 4 layers or 5 or 6 layers. That depends on the project. So data processing layer, where you will just right now, so we have product category as ELC, right? So something like ELC, that means electronics. MBL, something mobile or something like that. I'm not sure what it is, but some categories. Okay. So now we have some kind of dimension tables where you will have this ELC means electronics, right? So you will try to fetch what is ELC from different table, right? And get the product name, exactly name. Here if you could see product category, we have product code we have, but we don't know what is the product. Basically we don't know what, whether it is a any like mixie or grinder or stove, something like that. You are not you don't know, right, by looking at this data. So you have to join with some other tables where it has product category and product name. So likewise, you derive some new columns by joining with some other database, some other tables. So that happens in the DP layer, like deriving data processing layer, deriving new columns, and something like new columns, and some other transformations. Like transformations means like doing some transforming the data based on let's suppose if you could see this data, you can derive something. So based on the order date and delivery date, just derive a column called how much time it took to deliver the product, right? How many days it took. So based on this date and this date, So it took, in one day they delivered this product. So he ordered on that day, in the same day they delivered. So likewise, if you could see, he ordered on this date, and after 2 months it got delivered, right? Maybe not 2 months, so maybe this is 2 days, I guess. So likewise, you can create a derive a new column, like within how many days it got delivered, time taken for delivery. Likewise, so in this layer you will do these things, and then next layer, in this layer itself, at the end you will load it to Redshift, right? So this all things you have to automate it. You can't do it one by one manually, right? You have to create script and then create a pipeline, which script has to be executed next. So first you will execute the landing layer script, and then staging layer script, and then DP layer script, right? So then only your data gets processed from source to destination. So for this you have to create a pipeline. Okay, so that is what data engineers task are. So it seems to be typical, difficult, but it's easy. So if you know SQL, so mostly I want you guys to be, understand or write a SQL query, to be more complex. You have to work on complex SQL queries. So even if there is something new comes into your picture, like, in your page, if something new comes into your page, like, you have to work on Matillion tool. So Matillion is something ETL tool. Okay. So there are a number of tools. So if you go to Matillion, okay. So this is Matillion tool. Okay. So this is some kind of tool where you will transform the data only with this. Okay. If you have a requirement that in your project, once you enter in a project, so if you have a requirement that you have to work on Matillion tool, so if you know SQL, perfect. I mean, if you're good at SQL, it's a piece of cake for you. Like basically all tools, whatever tools, Informatica, whatever tools you have, that all, uh, will be on top of SQL only. So now if you could say DBT, so this is something DBT, so data builder tool. So this also works on top of SQL. So if you could see Snowflake, Snowflake is a database. Okay, that is a OLAP database. But whatever you do on top of that, querying purpose, so you use SQL. So I really want you guys to, advanced with SQL queries. Let's suppose if I give you some query, so you have to write it quickly. So that kind of level you should maintain, like expertise you have to maintain in SQL. And yeah, whatever tool is available in the market on data related stuff, so everything is on SQL. So just try to make sure that this particular 10 hours classes will be more of on SQL. You just try to install the softwares that I said, so you will be able to become an expert at SQL. So we will also discuss completely, real time related stuff. If you could see my training stuff, so we have SQL, right? So I'll share all these things. So let's suppose if you're trying to, create a database here. So once we do it in our laptop, in my laptop in the class, so I'll share this script so that you will be able to also execute in your laptop as well. So I also have real-time interview questions as well. Like let's suppose recently one of my student attended bank interview, bank who is a bank client. So they just asked few questions, kind of, um, like just to prepare a passbook. So basically they have given some data like this, and they asked him to prepare a SQL query where it has, closing balance at the end of every transaction. So likewise I also have, we will be also discussing on that kind of related real-time interview question stuff, as well as real-time how you will be implementing the project. So where, we have some kind of, um, you know whatever we do, right? So why we use where, so that kind of, in real time project, why we use where class. So why we use in operator, why we use in real time. I always explain what we do in real time. So it's not like simple SQL language that we are learning, like where is just to filter the data. So not like that. We will try to relate it to, any of the data engineering project, why you do these things. And we also talk about, we will be also talking about performance related stuff when coming to big data, and creating the pipelines, and if we have huge data as well, so that you will be able to answer advanced questions in the interviews as well. Yeah, we are going out of the topic. Yeah, no problem. Yes, Sandeep. So I think I answered your question. So you understood what data engineer does. I think even the YouTube as well, they also talked about building an ETL pipeline, ETL process, extracting the data from CSV files or tables, and loading into some data warehousing database called Redshift. I think they also answered in this way as well. So
Yeah, Vinay.
so is that the same thing they answered in the YouTube video that you explored?